multi-protocol label switching, we saw that it makes the path selection faster. It helps to find the exit interface much faster than going through a normal routing process. Normally, layer 3 is needed, which is very big, lot of frames or lot of portions in layer 3 header. Just to know one destination address, reading all of them, literally a waste of processor as well as the time. To avoid that, MPLS is introduced. When you add MPLS in between layer 2 and layer 3, based on the MPLS label, the packets are directed towards the destination by the router. I showed you some outputs like ceph table, forwarding base, binding table, and I showed you how the labels are involved there in deciding the path. I also told that MPLS header is 32-bit. In that 32-bit, the higher order 20-bit is for the label. So you should know now what's the maximum number of labels we can have. "20 bits you have, not just 8-bit, or even if it is 16-bit, you will have 65535. This is 20-bit. Plus, you have 3-bit for quality of service. So this 3-bit can be used for various other purposes as well. So there is a general name given for this called experimental bit. Experimental bit. Because the 3 bits can be used for traffic engineering, for QoS, for many other purposes. That's why it is experimental bit. It's not having one proper name. It's simply said as experimental bit because it can be used for any other need in future. 3-bit. And this is what we use for quality of service. This is what we use in traffic engineering. This is going to prioritize packet traffic engineering, right? And also we have 1 bit for telling the router whether it is processing the final MPLS layer or the before one. We call it as bottom of a stack bit. Bottom of a stack bit. 1 bit. If this bit is on, if this bit is 1, then it means this is the final MPLS layer. Yes, sometimes we have more than one MPLS layer. So the router should know whether it is processing now the last one or the one before the last. At last, we have 8-bit. Which is time to leave, right? So this time to leave is wonderful feature that we have in layer 3 header. In layer 3 routing, I mean, the loop never happens because the routing protocols are developed in such a way that the loop will never happen. Routing protocols like EIGRP using dual algorithm to guarantee a loop-free classless routing, OSPF having a router ID to guarantee a loop-free network, RIP using split horizon rule, and also the infinite metric 15. And if you take BGP, we have IBGP split horizon rule as well as AS path attribute to prevent loop. So the routing protocols, they provide only the best loop-free route to the routing table. As a result, there is no loop in routing. But there are chances that some engineers do wrong summarization. See, you may know how to do summarization, but before you do summarization, you have to study your topology very well and then decide whether the summarization is good or will it impact any other subnets of different prefix length in the network. So when they do summarization mistake, in doing summarization, loop will occur. The other reason is sometimes what we do is we do static routing, default route, static route. Then you have to take the responsibility of loop prevention. See, when you have routing protocol takes responsibility. But when we write static route, we have to do a thorough study of our topology. If not, our static route may cause loop. Now, how this loop is prevented if it is there in layer 3? This TTL. Time to leave in layer 3 header will make the packet disappear when it reaches 0. The TTL value when a device sends packet out like Windows computer, when I ping, for example, I say CMD ping 192.168.1.1, I can see the TTL value 64. Actually, I'm pinging my own gateway, the very immediate router. So when the packet is sent out from my laptop, it is sent with 64. How do I know? I'm getting a reply with no change to my TTL. Why no change? Because I told you, I'm pinging my gateway, my immediate router. Only when I pass through the router, the TTL gets decremented. When I pass through one router, the TTL becomes 63. Another router, 62. If there is a loop in between these two routers, 62, and then again here it will become 61, go there, become 60, 59, 58, 57, 56, 55, 54, 53, 52, 51, 49, I'm not going to say till 0, but what I'm trying to tell you is if there's a loop, when it hits 0, the packet is going to get, that disappearing. It gets disappeared. Yep. TTL helps to prevent loop. You may say, hey man, 255 hops. No, that will go in no time. In real network, the packet will vanish. It won't be there, causing lifetime trouble, blocking the bandwidth. So the TTL is good. Again, you cannot be comfortable with this loop. You have to fix the loop. If it is only one packet, it is okay. But millions of packets will be looping if the path is not properly defined using your static route or a proper summarization, improper summarization. Have to fix it as early as possible. But it won't go to a very serious level. It tries to suppress the problem which one the TTL. So such a nice TTL is there in layer 3. When you enable MPLS, you say, I don't want to see layer 3 where the TTL is. Then how about the loop prevention? That's why you have this 8-bit. So MPLS is not compromising on any of your quality. MPLS guarantees the same loop-free, loop avoidance by giving the same 8-bit. Now, when a packet enters into a provider edge router, see from customer, this is my computer. I'm connected to a router, and this router is connected to many other router, and this is the edge of the office. What is the name of this router? Let me see. Someone was asking this question yesterday. I answered. Let me see whether he answered.
Customers.
No, someone asked me yesterday about this.
CP.
CPER. Customer at CE. Now this customer edge, when it sends the packet out, let's say it is 52. TTL is 52. From 64, for each hop it got reduced and it has reached 52. Now when PE router receives it with 52, before sending it out, it decrements to 51, and that 51 is copied to MPLS header. Yeah, in this header, that 51 is copied. And now inside the service provider network, it gets decremented. When it goes out from here, it becomes 50. When it goes out from here, it becomes 49. And let's say there is another PE router here, because this is connecting to customer again. So 49, and when it is sent out, there won't be MPLS header, but there will be IP header, layer 3 header. In that layer 3 header, there is a TTL field, where there it copies that 48 and sends. So what I'm trying to say here is, though we don't look into layer 3 header inside the provider's network, inside the provider's network only we run MPLS. Not many. I've seen only one customer running MPLS in enterprises. Only one. When I went to the live network, I saw that. And another customer was telling in the class that they do have MPLS in their enterprises to make the network faster. But not many people. It is only used in provider network, provider, service provider, like internet provider. Now, even the provider routers decrement TTL. But most of the provider, they know that their network from here to here is loop free. So what they do is they tell the routers not to decrement. If you receive with 52, when you send it out from here, you send 51 and send. So the entire provider network between PE to PE will be seen as only one hop. I hope you understand this. Only one hop, the entire provider. For example, you see here, trace route www.google.com. Load of IPv6. I'm surprised to see they are using the private range of private FC00 and the FD00 is a private range of IPv6. And now I can see 24 and 2001. This is out of our India. I can say out of continent. And do you think to reach Google only 11 routers? Hello? Between my laptop and Google only 11 routers? No, no, no. No. Then why only shows 11? It is because between this PE1 and to this PE2, it is considered as only one hop because the TTL decrementation is suppressed in ISPs. See, TTL is good, but it's not really need to be decremented if there is a loop-free network. When you say not to decrement TTL value, your packet can travel long distance, isn't it? When you decrement for every single router, your packet can go only 255 hops maximum. See, when I was pinging, Windows machine sends packet with TTL 64, which means that it cannot go more than 64 hops. My packet cannot go more than 64 hops. But when I ping Yahoo, I'm able to get response. Do you think Yahoo is only 64th router or less than 64 routers away? No. This is the reason. My packet reaches very long distance, thousands of routers away Yahoo is. At least some hundreds of routers if you have some mirror copies. Now, how can I reach that far with just 64 TTL value? This is the secret. The entire ISP is seen as only one hop. So if you have 10 ISPs in the middle, then 11th hop you will be in Yahoo or what I was saying, Google. 11th hop I'm inside Google, right? So TTL decrementing can be suppressed. Right. So we got two new routers added to the yesterday's configuration. Let me try zooming it for you. So we got two extra routers acting as a customer, west and east. Needs a configuration, so I'll use Notepad or I'll use this document itself. Enable config T interface loopback 0. This is customer. I'm saying IP is 100, 100. Well, let's run OSPF. IP OSPF 1 area 0. And then interface F00. Interface F00. IP address will be 100.001.255.0.0.0. So instead of writing default route, I wish to go with OSPF, IP OSPF 1 area 0. And we are not going to run MPLS on the customer side. So the packet will be sent from the customer to the provider as an IP packet, not label switched packet, as a IP packet. What is it saying? Incorrect IP address. Oh no, yeah. I used here 100 on the loopback, so it will overlap. Correct. So this I'm going to make it as 110. Show IP OSPF interface brief. I can see OSPF running on both loopback as well as the physical interface. It's waiting for the neighbor. We have not yet configured router 1 F01. That's why it is waiting. Let us finish this east, then we'll focus on the provider. East is going to have loopback of 210. And this is going to be 200. And the mask is 24. All right. Verify. Show IP OSPF interface brief. We got OSPF. What next is make this provider and customer interact. Let me do straight away on the CLI. On F01, I have to configure .10. Router 4. .0.0.10 IP OSPF 1 area 0. I'll do similar configuration on router 1. Okay. I'm expecting neighbor in between West and router 1. Show IP OSPF neighbor. Show IP OSPF interface brief. OSPF is running on F01, but it is in a down state. Interface is not made up. Okay. I saw this down here. Hey, come on, I went to the wrong interface. Interface F01. Only now the neighborship comes. What about router 4 and west, east? They're already neighbor. Now, the moment I bring these two routers, I'll be able to ping between west and east. The reason is I have one common protocol. Between all these routers. So I'll go to west now. I'll try to ping east. Show IP route OSPF. I'm waiting for the routes to come. When I say 200, when I see 200, 10 or 200, it means that the middle routers are ready. Now you see the routes have come. I can see the loopback address of the east. As a result, when I ping from my loopback, I'm able to reach. But I want to show you that this is using labels. For that, I will say trace route. You can see the labels here. But in the real world, we don't see labels. The reason is you're going through a VPN between R1 and R4. I'm not going to get into that subject now. It's a later subject, MPLS VPN. Because you don't have VPN, here you can see every hop and you can see the labels that are used. We are going to walk through this now. So, sniffing. Let's see now. This is what we have. And when it is sent from here to here, it was sent as a normal IP packet. Do you see any label in this line? No. And when this router R1 sent to 1012, which is this guy, 1012.02, that's the IP of this router 2, it puts label number 22. What does that mean? According to router 2, 210.100.100.100, the label is 22. According to router 2, label 22 means what? This network. That is why router 1, before sending it out, it puts 22 and send to router 2. How router 1 knows that router 2 is using label number 22? LDP. This story we have already heard yesterday, but I'm repeating now so that you will have some confidence on what you have learned. Router two's local label is 22. I want to show you that. See, router 2 I have not even opened, but I am able to tell you that it is 22 assigned by router 2's LDP for that network. Like a magic, like a prophet, I'm saying here. You see, show MPLS forwarding table for 210 dot what dot I think 100 dot 100 dot 100. Correct. I told you label number is 22. And router 2 is sending to router 3 with the label number 19. You can also see that here. Outgoing label on router 2 is 19. Why? Because that is the label given by router 3. If you want to see that, you can go to router 3 and verify. Show MPLS forwarding table for 210. Local label is 19. And then the label given by router 4 is 18, which means in the trace route I should see 18 in the next line. Cool, that's what I see here. So it goes with the label number 18 to router 4. And router 4, when it receives label number 18, it understands that it needs to send the packet out on this F01 and to this gateway. But when it tries to look for a label, label is not there. You know the reason why label is not there. Because we did not configure MPLS in this link. Label is not there. I'll come to the story of pop label and no label. Now you should know what is no label. Don't think about popcorn, pop and all and ask question now. I'm not talking about popcorn now. Some of your mind has already gone to popcorn. Ask only about no label if you have question. Now to this destination, it is trying to push the packet. It knows the exit interface. It knows the gateway, which is router east address, but there is no label in it. Sorry, there is no label to provide. You can also see that in the CEF table, show IP CEF. For the 210, there is no label. There is no label. And you know the reason why it is no label. It's because you don't have MPLS on the direction. Right? Next. I'm going to trace route this time from west to 200, this address. 200 0010. this public address. So last time it was 5 hops. This time it is going to be 4 hop. Let us trace the route from west. 200.0.0.10 with the source. It's only 4 hop. Now, is MPLS running on router 4? Wait, no answer. Do we have MPLS running on router 4? Yes. Then why there is no label? Last time when it was going from here to here, we know that there is no MPLS. It was showing no label. We understood that part. Now we are pinging the address which is there right now on right on the router 4. Router 4 is running MPLS, even though F01 is not running MPLS. Router 4 knows about this 200.0.0.10. Router 4 can assign a label and give it to router 3. Then why router 3 is not using the label while it is talking to router 4? Actually, the label given by router 4 is a special label. Special label. Not Sada label. It is very special label. Label number 3. Router 4 is going to tell to router 3 that this network 200 is mine. Is mine. It is my network. How it says to router 3? By giving label number 3. Why it is doing that? So that router 3 will pop the MPLS header and send it to R4 without it. You see, when I ping from here to this address, if it comes with MPLS header, and then IP header, data link layer, the problem is this. I am not going to give to anyone. This packet is mine. When I receive with MPLS some label, let's say label number 50, for example, after I process this, I understand it is for my own connected network. So I need to do an IP lookup because I'm not going to forward it to anyone because it's an IP packet. I have to do IP lookup and then deliver to my own interface. It's unnecessary double lookup. That's the reason why. What is this? That is the reason why router 3 is asked to pop the MPLS layer, and after data link layer you will have only IP layer when it receives. So it reaches the destination, straight away delivers to this port. There is no need for 2 lookups. If you have MPLS lookup, then you have to do MPLS lookup and then through the MPLS header and then do the IP lookup and deliver to the IP running interface. It's a waste of lookups and time and CPU. So whatever the connected network routers got, they will send that special label 3 so that the neighbor router will know that I have to pop the label before I send it. This is what called as penultimate hop popping. For example, if you go to router 3 and check now, for the 200 network, if you see, it says popcorn. It says, I will pop the label and send it to this guy R4 without MPLS header. There won't be MPLS header when R4 receives the packet. You want to see that? I would like to show you. I'll sniff the packet here. And then I'll go to the west and ping. I'm in the west. I ping 200. You see, you got a lot of ICMP packet, and when you open, do you see any MPLS header? See, this is ICMP packet. Hope you read this Internet Control Messaging Protocol. And coming from 100.0.0.1, which is west, going to R4 PE routers, WAN facing interface. Do you see MPLS header? This is layer 3 and Ethernet layer 2. MAC addresses, you see. Is there MPLS header? No. But when I sniff the packet between 2 and 3 and do the same ping, you will find a label. You will find MPLS header. Now when I ping, you will definitely see same ping only I'm doing. I'm not pinging someone else. I pinged and the packet passed through, and you see now there is an MPLS header everywhere. Packet is actually going from 100.0.0.1 to 200, but you see a label number 21. Because label number 21 is what? The label used by R3 for 200. Let us go to R3. R3, is that true? Yeah, it says, yeah, my local label is 21. So you understood now what is PHP, what is POP, and you also know what is no label. Here no label because there is no MPLS. So that 210 network which is behind east is advertised without any label, so it was showing no label. But for that network 200.0.0.0 router 4 is not saying no, it is actually advertising label number 3 that makes this router understand that I have to pop the label. It is not meaning that it didn't receive the label. It received label number 3. That's why it has put pop label. If it would have not received label, then you would have seen no label here. Any questions so far? Alright, if no question, tomorrow we are going to get into some more details of configuring MPLS label manually, and then we'll get into VPN. Thanks for joining. See you next class.